Hello everyone, welcome to my YouTube channel Data Partnership. So this video is a continuation of my previous videos on evapotranspiration, how to use global data set Modis satellite product for evapotranspiration, so that it will help you in to identify the water stress areas and drought assessment, right? So you can use this data set for many purposes based on your requirement. So what I showed you earlier, that is how to use evapotranspiration data for for a particular locations, and then urban versus other areas, right? And how evapotranspiration anomaly, and what is the ET for dry and wet years, and how to interpret them, right? So I have done that. So I hope those are useful. So today I thought that this is worth to create a video on how it is trending, means what is the last 10 year what happened, right? So that's why this is I wanted to show you. So there are various section on this. Section one is that this is load evapotranspiration data similar to earlier one which we have done, right? So we are only using 80 bands. Everybody knows that how I did that, because if you see here, if you type here modis, then you can get the this detail, right? Modis data. So this one. So if you click here, then you will get all the details about this data set. You can read it, and and then we have bands. So we are using this 80, means this is total evapotranspiration, right? So it's a 8 day product, right? So this is, I have loaded this. So this I have just unchecked my earlier ETN memory. I'm just doing that. I'm using the same AOI which I have used earlier, right, in India. So this one is my study area. Then this is so the first step is to load the evapotranspiration data. I have just ET call. This is modest data, similar and filter dated 2015 to 2024. Then we have list the sequence in 2015, 16, 17, and 24. Then we have to calculate the annual. I have mentioned here also. This is the annual evapotranspiration. So we have created one function, right? So based on that, it will give you the means it will calculate the basically the annuality by per year, right? So so this is the thing. Then we have add time band for trend analysis. Then we will do the trend analysis where with time. So to calculate trend, Earth engine requires a time variable. So that's why we have calculated this. Here we add year as an extra band called time to each annual ET images. So we explicitly convert it to a float to ensure consistent data type, right? Then it is the linear trend calculations. This is the code for that, and then we have to display the things, right? So this I have already done, copy paste here. So you can check from here. You can use once we will. I have this mean annual ET, and how to if we run this code, then you will find such image, right? So the we two layers means ET trend per year and mean annual ET. So this is the mean annual ET, this green one. So light green. So light green means we have less, evapotranspiration. So similarly, if you just click here, this one, so you can get the mean annual. So mean annual means last 10 years data 228 point. If ET trend means this is minus 22, right? So it is minus. If you click somewhere here, then it is something. If it is coming in minus, it has different meanings, right? So it's happening, right? So up to the so what I will do is, if like this, what does mean minus per year, right? So if you in a particular location, if I clicking, if it is coming in minus 20 or 22 or whatever, right? So I'm talking about trends. So So if ET was 600 per year in 2015, it would be roughly 380 in 2020. It is coming down. So this is a long period drying signal. So a negative ET trend means the land is losing its ability to evaporate and transpirate water every year. So it means the less water is going back to atmosphere each year. So this is one of the concern. This can be one of the indicator of water stress, right? It is not the only one, but this is one of the means indicators. So that's why it help you the researcher and the professional to understand about the water stress areas, using evapotranspiration, using global data, open source technologies. So that's where, of course we will need other data set also. Soil, what is the soil requirement, what is the land cover type, what are the trees, what kind of area it is, and which season is it. So this is the annual, just annual evapotranspiration for mean annual for last 10 years, like what we used to do in rainfall also, right? So I hope this is very, I hope this can be helpful. So you can see, you can use this code and you can add, or you can maybe you can do more simpler, you can do in a more simpler way. So what I did, I just loaded the modis data, and and then we calculated annual evapotranspiration by using this function, right? And then we calculated mean annual ET, right? Simply, and then we have visualized it. Then we have added one additional band called time, you know, so for trend analysis. So this is the code for that. You can try it, and then this is the for the linear trend, and then we have finally we shows the image, right? So you can download this image also, so that you can use this thing in your QGIS or ArcGIS for your other purposes. You can overlay your basin area, your town area, your city area, or your whatever area you can say. So you can clip, or you can do it here also in Google Earth Engine. But sometimes it is better to do in a additional software, QGIS or ArcGIS, right? So guys, thank you, and this is that's it. So I wanted to show you. So please share and subscribe my channel, and improve these code, right? I'm also learning, and so that whatever I'm learning, I'm putting here, so that you can also get the benefit out of it, right? Thank you.